All right, so first of all, excuses for the slight delay, because GitHub has played on us rather amusing April Fools. So I had to rebuild everything like in a corner just before we start. Now, the good news is that the first part of the materials are just fine, so we're going to start on them. And then for the demo 2, we're going to hand out, we have 4 USB sticks, we're going to hand them out, so the demo 2, you have everything prepared there. We'll need a little break to get the project to everyone. Okay. So that's why I'm out of bread, because I had to run. And, okay. Alrighty. So without further ado, as Chris said, my name is Maren, and I really like RxSwift. So that's why I'm here today. Now, RxSwift is a rather large topic, and what I noticed is that some people would instantly like it and be excited about it, and some people will be instantly repulsed by it and hate it instantly after that. So I guess that the idea for this tutorial is to rush through a couple of concepts, and so every one of you can make their mind if you like it and you want to know more about it, or it repulses you, so you rather spend your time in something else. Okay. So, right, so let's start with the big question. What is RxSwift? Ta-da! So, RxSwift is it's a funny thing. It's a cross-platform standard that comes from Microsoft. They built Rx in their .NET platform some time ago. And it was so good that they decided to open source it. And actually, a lot of different communities have taken this open source .NET code and have ported it to different other platforms. So we have RxSwift for iOS, we have RxRuby, we have RxPython, RxJavaScript, and so forth. And they all implement the same API. And the good thing is that since it's the same API and the concepts are the same, you can just talk to your colleagues who are doing JavaScript on the web and discuss logic and things like that with them, because the API works exactly the same. Of course, with slight differences according to the language, right? Now, it's all about asynchronous programming. So, there's a lot to say about Rx and RxSwift, but it boils down to handling asynchronous programming and the complexities of asynchronous programming. Now, we're going to have a good look at what do I mean with that when we start putting code. The interesting thing about it is that it handles asynchronous programming by turning pretty much everything into an event sequence. So every change in your data, every update you do in some numbers or maybe data models is converted to an event that other parts of your app might be observing for. It works somewhat similar to Notification Center. I hope that all of you have used Notification Center. Whenever something happens, you can be subscribing for it, so you are notified with that. And Rx takes this concept to a whole new level. We're going to see how that looks like in a bit. The interesting thing is what people find scary with Rx are the operators. So there's this one thing that everybody's really excited, and there are operators here, operators there, and so forth. Now, I want to demystify that. What we call operators is just methods on this one class. So nothing scary in there. There's just a group of methods that are commonly referred to as operators. They help us do different things. We're rather going to see this in code because it's fun to write it. And what you need to the one thing that you need to remember from this slide is that it adds a level of extra safety to your asynchronous code. So everything that makes asynchronous code a little bit more safe and a little bit more fun, I think it's good. All right, so with that, what is wrong with asynchronous code? Don't we already write asynchronous code quite a lot, especially for iOS? Sure. All of the programs are asynchronous. I mean, we have UI, we have all the things happening at the same time, so we never really think about that. Well, yeah, that's true. The Apple APIs are really good. However, maybe they're too good, right? So we have Notification Center, we have Grand Central Dispatch, we have closures, which you can pass around in any kind of way you want. We have all these delegate patterns, data source patterns. We have so many things, and they all work in a kind of like different way. So in a full-fledged app, most probably you're going to use all of them in your code. And that's the thing, like it gets complex when you have to use so many different APIs that work differently. Just increases the complexity of your app. What RxSwift does, and does really well, is to kind of like get rid of all these patterns and all these different technologies by replacing them with just a single pattern, the observable class. And the observable class, as I said before, just represents all changes to your data as an event sequence through time, right? So if you have a variable, and then at first it holds the number 4, but then later on some part of your code changes that 4 to an 8, maybe later on other part of the code changes that to 15, and so forth and so forth. Rx turns that into this kind of like a sequence that goes through time, hence the arrow pointing to the right. And so that sequence can be observed from other parts of your code. So not only you have access to your data, but you also have access to the change events to your data. So when not only you can show a label on screen that says 5, or not only you can once update the UI with your data, but also every time this data changes, you will be notified and you will be given the new value so that you can update the UI or react to that change in some other way. So the observable sequence of events, the big gain, you don't have to be proactive about checking whether your data has changed. The data tells you when it changes, and you just need to react to these changes and update UI or whatever else you want to do with that new data. So kind of like, the initiative is now not in your hands. It's kind of like in the hands of your data to let you know when it changed. Really cool stuff. We're going to have a look in the code. Now, this is good, but how does that help us? Well, yeah, you can subscribe to observe this kind of data and build your logic around that. So this one, data sequence, this discrete values as they're being changed over time. There can be different parts, many parts in your app that are observing the same thing. Sounds a little bit abstract like this in the charts, but in code makes a little sense, don't worry. Now, what can be these observable sequences? Like, how is this in any way related to like what we do in iOS apps? Well, for example, here's a UI switch. This UI control that comes with UIKit and you've used a million times, most probably. So as the user toggles the switch, it has two states, right? Like on and off. Well, that is a event sequence. So as the user toggles it, there's two discrete values, which are false and true. So if you're observing for changes of the state of that UI switch, you will be receiving the true, false values, and so forth as this happens. So you can react by doing something in the UI or doing something in your code and so forth. So this is an example of an observable sequence, and in this case, it's an observable of bool. So the data that is being emitted over time is a Boolean. All right, well, this is pretty much the basics. So how about the operators? What are those? Real quick, for example, with our UI switch, as it emits true and false values as the user interacts with it, you can use different methods on that observable class that I'm talking about. And these sometimes, some of them look pretty much like the methods that you have on any sequence in Swift, like array or set and so forth. So we have filter, we have map. So you can say, hey, I want to react to the event when the user toggles the UI switch, but I want to react only to the true state, so only when the toggle is switched to true. So you can filter out all of the events that are for the other state. So you can react only when the user has turning it to true, then ignore the one when they toggle it back to off, and then react again when when they switch back to on. So filter, similar to how arrays work, but this one is asynchronous. Basically, it will work on your values as they happen over time. We have map, so maybe you want to change the true and false states of the UI switch to another type. You've probably used map with arrays. What map allows you is to take in certain type and then produce another type. So for our false and true values for the state of the UI switch, you might want to update the UI with something else, like a string. Now the button is turned on, or now the button is turned off, and so forth. So in the map, you can say, hey, if the current value is true, then I want to use this string, or if it's off, I want to use this other string. So you will find a lot of similarities between how sequences that are built in Swift, like arrays and sets, work, and how the Rx sequences work. The difference is that these sequences are asynchronous, right? Like they happen over time. Right, a rather rushed introduction. Let's waltz into the code. And hopefully, since we're all programmers, that will click faster like that. So, as I said before, the demo 1 was just fine in GitHub. So you can open up your conference materials and head to 11 RxSwift. We're going to start on demo 1. In demo 1, we're going to work in a playground just to try a couple of things and see how they work. And in demo 2, we're going to jump in a real iOS project and work more there. All right, let me open it as well. Okay. So you need to, probably unlike other tutorials that you've been in today, these projects use a third-party framework. So it's not something that is built in iOS. So Demo 1 uses CocoaPods to include RxSwift into your project. And therefore, in your project folder, you need to open the X workspace file. So there's a RxSwift Xcode proj, which usually you work with. But since we have additional frameworks in the project, you need to open the RxSwift X workspace. Let me double-click this one. OK, nope, the other way. All right. OK, and this is a playground. We've used CocoaPods to include it. You can here unfold pods, and here's all the sources of RxSwift as well. So if you feel like peeking inside, you're welcome to do that. Now, the first thing, as the top line says, the first thing to do with the playground is to hit Command B, or otherwise choose Product Build from the Xcode menu. Just give me a second here. You can click on Product and then Build, or just get Command B. You have to do this so that Xcode will build this external framework, and you can use it from your playground. Now, at first, when you open the playground, you should see an error next to import RxSwift. This will tell you that the framework hasn't been built yet. And as you build it, this error needs to disappear, just like here on my Xcode. Sometimes, just sometimes, Xcode will build it, but not rerun the playground, so you won't see like things happening. Then, just check quickly in your Xcode that here, this one button is not a triangle. It needs to be a stop sign. So if it's a triangle, just click it, and this will run the playground. And then on top, okay, this is a grand tour of playgrounds in Xcode. This is the last thing I'm saying. On the top, you should see running RxSwift. Now, this does not mean that Xcode is still working on something. This means that actually the playground is running, because it's running all the time for you. It's running indefinitely, right? OK. Right, and so we have an empty playground, and RxSwift is already imported. So here we can try a couple of things. We're going to start with the easiest class in the RxSwift framework. So like any framework, there are a few classes included in this framework. They do the work. Sometimes I hear people complaining that there are classes in RxSwift that they need to learn about. Otherwise, it doesn't work. Like there's few classes, new classes that you have to kind of like know about, right? Okay. Yeah, that is. People have complained to me about that. Right. So the first class that I want to introduce you is called variable, and variable is good for beginners because it really works similarly to how built-in Swift variables work. So it's kind of like an intermediate step towards a good concept. So let's have a look. This one, I'm going to call it names. Yeah, there it is, names. And we need an instance of variable, like so. Oops. Now, this will happen a few times for you as well. Xcode is very unstable software, so sometimes it will just close the playground by itself. If that happens to you, just click back on the playground file and we'll just reopen it. Right. Not my fault, I'm sorry. That's just how Xcode is. OK, so we created a new variable, and you might need to, OK, there it is. We see there we created one of those. Now, variable, it also takes a initial value in the initializer, so we can put in an initial value in here. So in this little playground project, what we're going to do is kind of simulate a chat room. And names is going to be the names of all the users that are in the chat room. So naturally, since we will need a list of strings, which are going to be the names, variable will hold an array of strings. So I'm going to put in here an array and then one name inside. I'm choosing to have Peter in here. All right, so there you go. Now we are doing reactive programming. Really nice. Now, so what variable does is just to hold a value, which you can set at arbitrary times. However, as you change that value, a variable will emit an event with the new value to everybody who's interested in it. So it will give you a chance to react to changes to that value. You can just type in names, like so, and then value. And then this will print on the right-hand side. It will show you what is the current value that variable is holding. OK, that doesn't really seem too complex. So how do we react to changes with variable? Let's do it. So we will say names. And then names has actually just two members. One is the value itself, and the other one is a method called as observable. So observable is this event sequence that I was telling about. Observable is this one that you can observe for changes. So let's choose it. Right. And as observable gives us now a sequence that we can subscribe to for changes, react to them, use those operators, and so forth. Now let's do a subscription. So I will come here on the next line and type in a dot, and then you will see all the methods that you can call on an observable class. And those are plenty. The one we are interested in is called subscribe. However, there are a few variants that there are. So you've got to choose the one here that has a lot of parameters. Right? There's 4. I mean, not too many, but that's the one that we are interested in. OK, and so here you can provide 4 closures. One is called onNext, the other one is called onError, the other one is called onCompleted, and the final one is called onDisposed. So these are pieces of code that you can provide, and Rx will take care to call whenever each of these types of events happens. It's pretty easy. Actually, we are going to delete everything in here. you just need the onNext one for now. And onNext takes in a closure, like so, and one parameter in. So in here, the parameter, I'm going to call it value. So here's what you need to end up with. OK. There it is. Am I using the biggest font possible? Presentation large. OK. All right. So the interesting thing is now, anytime you change the value of variable, RxSwift would take care to, and this is called a next event. Like next is kind of the next value, right? The next discrete piece of data you're having. And so now in this closure, you can decide what to do with this new piece of data. And the interesting thing is that you get this new piece of data inside the closure. So you own it, it's in your closure, and you can decide what to do with it. I'm choosing to, as any intro, just print it in the console. So I'm going to say print value like so. And as soon as you do that, the playground will run, and you will see in the console here, there it is, the actual value that is there. OK, so instantly, we had this block called with the value that we have in variable. OK, so this is, it looks easy, right? Like you can just subscribe, and then you can do this from different parts of your app, and you can always just react whenever the data changes. And in this example, for example, the names variable will be in your, I don't know, networking layer or so. So this will be the part of your app which talks to your chat server or whatever. So this is where the new list of connected users will come. And then you will do that observing part, maybe in your ViewController, on your view model, and so forth. And then in these view-related parts of your app, you will just react to as the data changes. Right. So we see that instantly it adds like a level of abstraction that helps you instantly split, data manipulation and data processing. So what we're going to do next is, so I'm keeping an eye here on my notes because nobody wants me to get lost like during, right? But that doesn't mean that I don't know what I'm talking about. So if you feel like posing a question like in the moment, just raise your hand and ask, right? OK. So let's see how that works. Let's change value and see what's going to happen. So I'm going to type in names and then value, and I'm just going to provide a new value in here. Since this will be a chat room, Peter will still be here, and then I'll put another name called John, for example. So as we do that, we see that now in the console we have the two values. So Rx called that closure 2 times. Yes. Right. So the question is, why do we have this array in there in the initializer of the variable? Well, the variable holds one type of value. It can hold one type, right? So yeah, it can be anything. So if we put in there a string, then it will be emitting string values. Right here, we use an array because we're talking about a list of names in a chat room, but it can be anything, right? And so yeah, this value that you receive here in the subscribe in the onNext closure is the type that you specify initially in there. OK, and so we can, let's add another line here. Let's change the value again. Let's call it, I don't know, let's add some diversity. Let's say Alice and Wendy are here, and then Peter and John are gone. They left the chat room. So as we do this, we see that there is now three printouts in the console. So every time there's a change to that value, your closure will get called with the new value. Right. OK. So it is kind of like Notification Center, right? So you can observe for new events, and then somebody else can emit them. But you also get typed events, right? Like we said in the beginning, there's going to be an array value in there. So every time you only receive this array, and then you receive it straight into that block of code. So it's more structured, and it's more straightforward. And also, this happens asynchronously, right? So here, this code is pretty much synchronous because it happens right after one after another. But we can change value within a few seconds, and that will still call that same closure. So the playground already includes a function called delay, just a Grand Central Dispatch kind of delay thing. So let's do that. Let's delay for 2 seconds, and then in the completion block, say names value this other thing. So I don't know, maybe Alice left, and then there's just Wendy left now. Here it is. So now you will see the 3 values being instantly printed to the console, and then after 2 seconds, you will see Wendy pop up as well there. So pretty easy. And then copy this one more time, the delay block here, and then give it a 3 seconds this time. And then in the last line, the last name that is being added after 3 seconds, put in admin with the capital A. Right. So kind of like the admin of the chat room logged in. And then you see like all of these are getting executed as the values being changed. So as I said, this is pretty handy when you want to separate the responsibilities. You'll be modifying your data from one part, which is responsible for that, and then you will be observing for changes in the parts where you want to basically do something with that data. Okay, let's try a couple of things, the scary operators that I've been talking about. Scroll back to as observable, and we'll add a little bit of code in between subscribe and as observable. Subscribe needs to always be last here, because subscribe is what kind of fires up the whole observation thing. So when you create an observable, nothing happens, absolutely nothing. It's just code definitions. It's just closures of code. When you call some operators on that observable, like filter, map, and so forth, still nothing happens. It's just definitions. Now, when you call subscribe in the end, this actually tells the observable that somebody wants to observe for data, and only then the observable will produce some values. So let's insert some operators in here. So just after as observable, type in that dot and choose filter. Okay, I'm going to delete everything in here and just put in an empty closure. Filter takes in one parameter. This is the new value that is being emitted asynchronously. And in here, we need to say true or false depending on whether we're interested in that new value or not. So just like when you filter an array, right? The difference is that the filtering an array happens synchronously, right? Like you have the whole collection, you decide what gets through and what not, that's it. With the observable, that happens asynchronously upon each emission of a new value. And so here we want to say, we're interested in only in the updates when there's more than one user in the room. For whatever reason, maybe we want to show some UI things and so forth. So here we can say return value, and as I said, value is an array because the variable holds an array. So here we can say value count more than 1, like so. So now every time there's a new update, the observable will emit that new value, but then filter will decide whether we want to react to that new value or not. And if you look at the console in there, you will see that we don't really see anymore all those values we had before. We just have the ones that had more than one element in there. So this is the way to to filter which events you want to react to and which you don't want to react to. Now, as I said, the important thing is that all this happens asynchronously, right? As there's new values come in, this whole little chain will get executed to decide whether you want to do something or not, and so forth. And we can chain them like this, not because of some magic, but because each of these methods, like filter and map and so forth, actually returns back also an observable class. So you can just call them one after another, and they will be executed one after another in the precise sequence that you write them like that. Now, this is very interesting because some of those operators can be asynchronous as well. So you kind of like write this synchronous looking code that can be also asynchronous. So one of these operators can potentially call a server API, wait for a response, get some JSON back, do some processing, and only then complete. And then the next block is going to be called whenever that finishes. So it's really good when you're writing potentially asynchronous code, because you can just write it like this, one after the other, and then that sequence, that order will be observed and preserved. Let's do another one quickly. Let's say .map. So let's see how we can change the type just in the middle like that. Map also takes one parameter, so we'll say .map value in, and then here, right now we have an array of strings. Let's convert that to just a string that we maybe want to show in a label or so. So from map, I'm going to return a string that's going to say users, and then just I'm going to put in value in here, so a whole string like so. And now here we are not printing an array anymore, but we're printing a string in the console like so. There it is. That's our string. So that's a big concept with Rx. Filter takes in an array and returns an array, but map takes in an array but returns a string. Because in our subscription code here, if we're not just printing, but if we are updating the UI, we might want to update a label that just says, these are the users that are currently in there, or text view. So in the end, we'll need a string. To show what I mean, we can do a quick thing in here called debug. So one of these so-called operators is called debug, and you can put it in between basically anywhere in the chain, and you will see what comes in at this point of the code. So just right after filter, I'm going to put in a debug like so. Just no parameters like that. .debug, no parameters. And then when I zoom in here in the console, you will see it tells me which file, which line, and what happens. So first, it says, hey, there was a subscription to that observable sequence. And then a next event that sent that value, and then another next event that sent that other value, and the value itself. All right, and this is obviously an array, like so. Now, if we grab debug, remove it from here, and put it just after map, like so, we'll see something different. We'll see now the string being there. It looks very similarly, the output. It's just that the next event, the value is a string. So you can, if you're not unsure what happens in between this and that operator, you can always insert there a debug and see the output, see when happens, which lines, and so forth. OK, now that's almost everything that I had for this first demo. Maybe, Chris, how are we doing on time for this first one? Is there like 2 more minutes, or that's it? Yeah, OK. Oh, cool. All right, so let's try something else. Yeah.
You said that the .subscribe was actually the first thing that got run, even though you have it listed as the last in your list there.
Right.
And it even prints out there first.
Yeah.
That seems backwards.
I know. Right.
That's all you know.
No, right. So subscribe happens first because debug actually outputs all the events there. So in your observable sequence, you have few different types of events. So first, you create the subscription, and that's why it says here subscribed, so that you know that the subscription is activated, kind of. And then the next thing that happens is that it emits one value, and then it emits another value, and all of these are the next events. So kind of like here, the first output is it tells you that now the subscription is created. If there were no values emitted instantly, then there will be just subscribed, and the observable will do nothing until there is one new piece of data emitted, and then you will see the next event there. So these two are not bound together. They can happen separately. So you can create the subscription and just wait until there's something to react to. And then there's a special case, for example, when you know that there won't be any more values being emitted, so kind of like the job is done. And the observable can say, hey, I've done my job now. So then you will have a completed event to which you can react in a separate closure. You saw that subscribe takes 4 different parameters, right? And right now we're just reacting to next events, which carry a piece of data. But we can say on completed something else. So whenever the observable has done the job, it will tell us, hey, I've completed my work. So we can do some wrap-up of sorts. A good example is when you're downloading a file, you kind of like start the job of downloading a file, then you receive these pieces of data as they come in from the internet. And then in the end, the file is completed, so you know that there won't be any more pieces of data. So if we make the parallel, the observable, the subscription will happen when you start downloading the file. Then as data comes in, that will be discrete values that the observable emits. And then finally, when the file is downloaded, you will receive a completed event, so you know that the job is done. OK. What I wanted to wrap up with this first demo is you might have a wrong perception that all the operators are kind of like the same as in the built-in sequences. But even though there's many similarities like this, like filter and map and so forth, there are also different ones. So let's do one of those. I'm going to add one more in here. Just after as observable, let's use one called Throttle. T-H-R-O, and then you will see Throttle. And let's use the first one that has 2 parameters. So Throttle is, since these values can come in asynchronously with some kind of like time interval between them, Throttle is kind of like a time filter. So you can say, hey, I want to react to new values, but only if they have at least half a second apart. So in our example, if users are connecting very fast, new people are coming in, maybe you don't want to update the list of users like every microsecond. You just want to do it like at minimum like half a second apart. So here you can say Throttle, and as first parameter use 0.5. That will be half a second. OK, there it happens again. OK, 0.5, and then for scheduler, scheduler is kind of it's kind of like a task queue. And in here, what we want to do is we're interested in the doing these things to update UI. So we're interested in the main queue, surely. So here we're going to use a predefined scheduler called main. I'm sorry. What is it now? Sorry, this is absolutely out of my mind. Oh, I have notes. Wait a second. Surely that's called main scheduler, but no autocomplete. Ah, there it is. OK, it's called main scheduler. For whatever reason, the autocomplete didn't really kick in for me. OK, so this will do this time-based filtering on the main queue for us. And here it is. Now that we have a throttle that filters out any events that don't have at least half a second apart, you can see that the output in my console now has just one value, which is Alice and Wendy. So here I've emitted Peter and John, and then I emitted Alice and Wendy, but that's basically 2 lines, right, one after the other. So there is no half a second. So the first one got filtered, and we kind of like used the latest one in there. Now, if this was not just Wendy, but it was just maybe another name. Hey, my name, Maren. Now, this one we will see first. Alice and Wendy will show up, and then also Wendy and Maren shows up because there was half a second. So there is a bunch of these predefined methods that do common tasks, like time-based filtering. But there's plenty more. You can use, I don't know, plenty for sure. For example, you can have batches. So as elements come in, you can use a window operator to, it's called window, to group, say, you're interested in all of the values, but you just want them in batches of 3. So whenever there's 3, you will get them, and then Rx will just buffer the next ones until there's 3, and then we'll give you another batch of 3, and so forth. Or you can use, you can combine 2 of these together. So if you're interested in both the names of the current users and whether the device is currently connected to the internet or not, you can combine these 2 pieces of data and use them like from the same place in the same subscription. Interesting stuff. All right, so Chris, I guess we're good on time for this part of the demo, right?
What we did in demo 1 was use a variable that
you can, at arbitrary times, change the value of, but you could also read the value property. So at arbitrary times, read and write. And this is exactly what Rx's big idea is to get rid of. Because many parts can actually change the value and then at arbitrary times produce new values and so forth. So what Rx aims to do is to eliminate that possibility of multiple parts to asynchronously change the same piece of data. The proper classes like publish subject and behavior subject, which a variable is a wrapper around, those don't allow you to read the value. And that's the big idea, that you cannot at arbitrary times decide to check what the value is. The idea is to allow you to only react to new values whenever they're emitted. And so this way, you only react. You never reach out and say, hey, I want this new value to be in, and so forth. And this is what we're going to do in the next part. We're going to move away from the variable pattern that allows you to do this arbitrary stuff. And we're going to move more to code that just reacts as events come in. All right. It looks like everyone's got the files. Anyone who doesn't have the files. Amazing. OK. All right. So quickly, a few slides to give you some context on what we're going to be doing in Demo 2. So now it comes the in-practice part. We're going to take a iOS project that already works in a way, and we're going to do a few things there to see how applying Rx in an actual iOS code looks like. So one of the interesting things that we're going to try is combining observable sequences. So what we did in the playground was have one kind of sequence and then react to it. But what is more interesting is to take few of them and react from the same place to any change in any of them. You're going to see how practical this is. But here's how it looks like. For example, we have a switch, just like as we discussed previously, that emits true and false values. This is an observable of Boolean. But you can have also a text field. And the text field, as you type in characters in it, emits these discrete values, which are the current text in the field. And that will be an observable of optional string. Why is it optional? Well, because for whatever reason, when the text field is empty, the value is nil, right? So this is how it's built in UIKit, right? And for example, you can have a button that can be pressed and normal, a normal UI button. And this could emit discrete values, which are the state of the button, whether it's pressed, whether it's not pressed, and so forth. And this will be an observable of UI control state, the property of UI button that denotes what kind of state is it in. And in any app, you can have many of these controls together in your UI. And they all kind of can affect the UI, how it looks like. And the good thing with Rx is that you can take all these observables, all these sequences of different discrete values and combine them together into one subscribe block, where you will have the latest values of each of these as they change. So in this one place, it will be where you update your UI. OK, so composing sequences, this we're going to do in Demo 2. Another thing that we're going to do is when I say updating the UI, with Rx it's pretty easy. You have these discrete values that come from a text field, for example. So in your subscribe block, you can just say mylabel.text equals the latest value, and this will already update your UI as your data changes. The good thing about RxSwift is that it implements what is called data bindings. So the people of Vue who are maybe have written or maybe just played with Cocoa on the Mac, you know how amazingly easy it is to bind like a array or a piece of data to a UI component. I mean, it makes sense as your data updates, to update also the UI. And Cocoa on the Mac offers that automatically. But UIKit does not offer that on the iPhone. However, RxSwift offers that. So whenever you have an observable of string, you can use bind to and give it a label, and then Rx will take care to automatically, whenever your observable emits a new text, to also update the label that you gave it. And that works for different types with different UI controls. So a piece of text, you can bind to a label. But if you're fetching some JSON from internet and turn that into an array of some kind of objects, you can use the same function bind to bind this list of objects directly into a table view. So anytime the list of objects you're fetching from internet changes, Rx can automatically update your table view without the need of delegate pattern, data source pattern, and so forth. And this we're going to do as well. And the final thing we're going to do, and actually this we don't exactly going to do, but we're going to have a look at how it's done, is how, we speak about observables, so we're going to have a look at how to make a custom observable. So we're going to see quickly at actually how it works, how to create a new observable of some sort that people can observe. We're going to have a look at a simple observable that uses a timer to make a network request, get some data back, and emit the response as a next event that other people can observe and react to. So we're going to have this class that has the timer, then repeatedly makes the network call, and whenever there's new data back, it's going to emit a next event that people can subscribe to and update UI and so forth. All right, and with that, we're going to work through demo 2. All right. So what played us a bad joke here is that I wanted to use one project with CocoaPods so that you can see how it works with CocoaPods, and one project with Carthage to see how it works with Carthage. However, a git ignore file came from somewhere that ignored the built Carthage frameworks. So I had to rebuild everything like just before the workshop, and so we can distribute it. However, when you open demo 2 from the USB stick, you will just open the Xcode project file. So there is no workspace file since this is not a CocoaPods file. Here it is. So demo 2 starter when there's stock. There's just an Xcode proj which you need to open. Let me just check if I'm on the correct Xcode. Yes. All right. So this project is very simple. There is one ViewController in here, and that app will show stocks, live stocks, that their price changes instantly, over time, all the time, and then our app using reactive is going to, show that on screen. And the top of the UI, we have a UI switch that I've been using for, to demonstrate how observables work like for so long, that we'll be able to toggle on and off to see only our favorite stocks and also all stocks. Then there is a search, where you can enter like a symbol or a part of a symbol and then filter all the stocks we see. And then under there is a table view where all the symbols show up. Actually, if you run this right now, oops, wait a second. If you run this right now, you will see how the app looks like. Okay, maybe I can do this a little larger. Oh yeah, there it is. Okay, so here's the 6 stocks that I'm, for whatever reason, interested in. There's show only favorites, which I can toggle, and there's search, where I can enter things, but nothing really works. And some of those are already favorited, but there's no prices. So there's a lot to do in that app. So I hope that you're ready to work hard. Right. The good news is there's not so much about the app. There is just one ViewController, one cell class, and basically a mocked API. So you don't need internet, you don't need network for that to work. So right, let's start by having a quick look at ViewController and see what's in there. So first of all, there's 2 imports on the top. One imports RxSwift, and RxSwift is the cross-platform standard of Rx, right? Like this is what each library on Python, Ruby, and JavaScript implements. So these are the observable and the observer classes, variable class, and so forth. Now there's another import in there called RxCocoa. Now this is the UIKit and Cocoa specific functionality on top of RxSwift. What RxCocoa does is to mostly, I mean, there's different things in RxCocoa, but what we're going to be using here is the extensions that RxCocoa adds to various UIKit controls, like the switch, the text field, and the table view, and so forth. And so RxCocoa adds extensions that we can use directly. So we can grab directly an observable that gives us all the discrete values of a text field or all the states of a UI switch, and so forth. All right. Quick tour of the code. So first here I have the list of symbols that we're going to be using. And then here I have a variable called all prices. So you already know what variable is. And here the variable contains an array of stock price objects. So as we said earlier, the variable can contain anything, an array, a primitive, and so forth. In this case, we use a list of stock price objects. And stock price, if I drill down, it's just basically the data model for one stock. It has the symbol as a string. It has a flag, whether it's a favorite or not. And also, it contains the price. All right. And we have all prices, which are basically all the prices. And we have another one called prices. So this will be basically the filtered list of prices that we're going to show in the table view. So when we say I want to see only the favorites, we're going to filter all prices, get the favorites out, and store it in prices, and then show that list in the table view. There's few outlets: table view, favorite switch, search term, which is the text field, and then in ViewDidLoad, initialize the stock prices, and then here is we just assign whatever we have in all prices and prices. So that's why we see them instantly in the UI. This we're gonna get rid of in a second. A little further, there's the table view methods here that drive the table, right? The standard number of rows in section and the standard cell for row at. And then even further, there's a few couple of util functions that we're going to comment on later. So it's really simple view controller that we're going to start working with. Now first come here to the ViewDidLoad. And as I said, this one we won't need anymore because now we're going to implement that filtering of the prices. We're not going to just use straight away all of them. So this, I'm going to comment it like so. Or you can delete it, comment it, whatever you want to do. Right. We're going to do a huge jump here, so don't get scared. First, we're going to combine the observables of the favorite switch, the text field, and the list of prices. So all of these are observable sequences, and we're going to combine those in one place and react to any change in any of those. So scroll down to bind UI. This is just a name I like, bind UI. This is where I just like to call that method like that and just do my UI bindings in here. So let's type in observable. This is the observable class, and then type in combine. And then when you type combine, you will see plenty of different autocomplete suggestions. So you can. The difference is that some variants take 2 sequences that you can combine. Some of them take 3 sequences that you can combine. Some of them take 4 sequences, and so forth. So choose the one with that has source 1, source 2, and source 3, but not source 4. So the one with the 3 parameters. And here we can combine few observables into one. The first parameter is going to be the all prices. Here it is, all prices. That's a variable. That's where we store all the current prices. We're going to type in as observable. So anytime the prices change, we want to get notified. So we say all prices as observable. Put in a comma, and then we move on to the second parameter. The second will be the favorite switch. There was an outlet already connected to the UI, so we say favorites switch. There it is. And then what RxCocoa does to all of these UI controls is to add an Rx property, like so. And then the Rx property itself is a collection of different things. So you put in another dot in there. And here is all the things that you can observe on that UI control. So you can explore also on your own. So you can see here we can subscribe to changes to the alpha of this component. You can subscribe to changes of enabled and hidden, is on, and so forth. So all of these you can react asynchronously to. What we are interested in is on. Is on is the property that emits a value whenever the user toggles the switch. OK. So anytime the user toggles the switch, we're also going to get notified. The next parameter is going to be the filter text. How is it called? Search term. Is the all these are the outlets that were on the top. Search term, same thing. Type in Rx and put another dot, and then you can see all the properties you can subscribe to on the text field. Again, a lot of things in here. What we're interested in is the text property. So this will give us all the discrete values as the user types in something in the field, as they type in this value. Right. Very nice. And then the last one is basically the closure that was going to get called anytime any of these emits a new value. Right, so put in here an empty closure, and then this empty closure takes 3 parameters, which are the 3 current values of these 3 observables. So if the favorite switch emits a new value, you're still going to get the latest value from all of these 3. So that you don't have to poke around to look like what is the current value of those. You will always get the latest value from all of them. So you can just really easily take these 3 parameters in the closure and do the updates you want to do. So yeah, let's see. First we have the prices. So this parameter I'm going to call current prices. The second parameter I'm going to call only favorites, because this is the favorites toggle. And the third parameter I'm going to call search. OK. Then put in. All right. So this closure is going to get called every time there's any change into any of the 3 observables. Now, inside the closure, I'm going to put a print for now, just to give it a try. So put in print and just print the 3 parameters, just to see it work. Put in current prices. Then I'm going to put on only favorites. OK, and then finally search, like so. Now, right now, this won't do anything. Because as I mentioned before, when you activate the observable is when you call subscribe. So before you call subscribe, nothing will happen. This is just the definition of possible workflow. Only when you call subscribe, that will actually trigger things work. So for test purposes, we'll put in a subscribe in here and just use the subscribe without any parameters. Because we're just interested in the print in there just to see it work. Right. Yep. OK. All right. Beard problem solved. All right. So now if you run it, though, you can see what this is going to do. As we said, we have a little warning, ignore it. So now when you run it, you see that stuff happened. First, we don't have the stocks anymore in there because we removed that line that just copies them blindly over. But now, if we look at the console, we're going to see here what we're going to see. First, there's an array of vendor stock price objects. There are 6, and then there's a false. Sorry, here's a false, and then there's an optional empty string. So as soon as we call subscribe, we receive the current latest values of all of these observables. And these are the 6 prices we already have in all prices, false because the switch is not toggled, and then optional empty string. And let's click on toggle. There it is. Then we got a new print in here that shows the latest prices that we had true and an optional empty string. And then same thing is going to happen if we switch over to the app and then just actually type in here something. There's Maren. So here we can see the text field emitting all the discrete values that are in the text field as I type in. And you see I receive all the latest values from all of them together. So this is pretty handy. You don't have to poke around and pull latest data from all these components. You just combine them together in the same subscription. And now you can do the updates on your UI. Now first, let's get rid of subscribe. That was just a test. What we actually want to do is to come in here when we send print, maybe comment print as well. Just we don't really need it printed in the console. We want actually to do stuff. So in here we're going to do what we're going to do. Well, we have the prices. We have whether we should filter favorites or not. And we have a search string. So we can actually take prices and filter out the stocks that we're not interested in right away here in the closure. So follow me here. We're going to say return current prices filter. And then filter takes, of course, current element, which is beginning price, and returns a Boolean. OK. Now, since we're going a little meta in here, I need to clarify. This filter on current prices is not an Rx observable filter, because here inside we got the latest value, which was a list of stock prices. And we are filtering this just as a normal array. This is just the array of the prices. And we're just using filter to filter out the ones that we're not interested in. Right. So this is the synchronous filter. The other one that we used the previous time is the asynchronous filter. OK, so what to filter out? Luckily, I've already written the function that actually filters the collection. We're not interested in to loop over all the elements and discard the ones we're not interested in. We will put in here return. And the function is called should display price. And takes a price, which we already have in there. Takes only favorites, which we already have. And a search string, which we already have. Well, I wrote this function specifically for this use, so surely everything matches there. So, yeah. So here's what we end up with. Anytime anything changes, we take the prices and then we just filter the array of prices to what we actually need to use. And now we can chain another operator down to update the table view. However, we don't really want to directly update the table view. We want to copy the filtered prices to the prices variable that we saw first there. So if you scroll up here, you saw that we had all prices, which was everything, and then prices, which we're going to use to update the table view. So we're going to take all prices, filter them, and save to prices. Now, how do we save to prices? Do we just set the value of prices or something like that? Luckily, we can just bind directly to prices. So come in here, under the closure is finished, and just say bind to. And then put in here prices. Right. And so Rx sees that you output an array of stock price objects, and you provide as a parameter prices, which is supposed to store this kind of type. So it just says, OK, well, I can figure out what to do. Just we'll take every new value and just store it into that variable. If you put in there a label or something else that Rx can figure out how to update, it will just update it in this way. There's one last thing you need to add in here to clear that warning in there, which is one last call, which is add disposable to. So there's not many choices here. Just choose the first one, add disposable to, and put in here bag. Ta-da! OK. Now, we did not completely did not mention that at all so far. So bag is a property on the ViewController. I just defined it here. And it's just it's a way to make these subscriptions not leak, because they're asynchronous, right? So they can happen at arbitrary times. And you never really release them or retain them in any way. So this is how Rx works. When you call subscribe or bind the data somewhere, you just say, I want this subscription to be kind of bound to that one bag, because you throw in different subscriptions. So whenever you pop the ViewController out of the navigation controller, that controller will release its properties, right? Like normal. And one of these properties is the bag, because it's a property on the ViewController. And the bag, as it's dying, will release all of these subscriptions that you threw inside. So this is how they're going to be released from memory automatically. So you don't have to call any release or so forth in your view to disappear or something like that. OK. So now we can, just as we did before, react to changes to price and update the table view. So I'm going to do this directly like so. After this code, put in prices as observable, just as we did in demo 1. And in here, we want to say subscribe. Choose again the one that has many parameters. Again, delete them all. And leave on next only, like so, like just as we did in demo 1. And then in the closure for on next, put in value in, like so. And this will be the new list of prices we want to do. However, how do we update the table view with the new data? Well, like usual, we're just going to call reload data. So actually, we won't use value at all. We're just going to say here self table view reload data. And if you don't want to leak memory, you can also put in here weak self. And then add a question mark in here. OK. And again, you see the warning, which tells you, hey, this subscription, what are you going to be doing with it? Again, just exactly the same thing. Add disposable to bag. So this subscription will also be released whenever the bag is killed, which is going to happen when we release the ViewController. So we have, so this is the basic concept of data processing with Swift. We have one subscription that gets data, filters it, processes it, stores it somewhere. We have another subscription that every time this stored data is processed or have new value, updates the UI. And so these two you can split again in different parts of your app. The lower, like the latter, will be somewhere in the ViewController because it updates the UI. The other one will be maybe in your view model or whatever class you're using to do your data processing, networking, whatever. You can have the two completely separate. All right, so yeah, let's quickly run the app. And what we're going to see is here are the prices. That's nice. And now when we click here, they're filtered because anything we do now here, anything we change in the controls will trigger that combine subscription. Here it is. And that will trigger the reload on the table view and so forth. I can type in here, what is it? Something that we have in more, what is it? K. All right. So here we filter those ones. Then I can say, hey, but out of those ones that have a K in the name, I just want to see the favorites, like so. So it makes it quite easy when you can, combine these together and then react in a single place. All right. Chris, how are we doing on time? How much do you think I have left? 10 minutes for your lab, if you like. All right. OK. Yes, I do want to have the lab in there. So what we're going to do is, sorry for the delay. Like this, the files thing was really ate up a little bit of the time, so we can't really figure out to do like with this 5 minutes that we have left here. But it's more important to start on the lab at least, to see how to do more things in the UI. So what I would suggest for you to do is open the folder, find the lab, lab folder, and then in lab there is a starter which continues just about 5 minutes after what we just did. But it will be more interesting for the ones of you who are fast to try to finish the lab, and for the rest you just work on this afterwards at home, at the hotel, and so forth. So the starter in the lab, open it up and just follow through on the lab document. And if you don't finish the lab, don't worry, because tomorrow morning I'm going to be available at I think 9:45, just after the first session. I'm having my lab in the Bell room. So if you feel like, if you're super interested and you really like RxSwift, you can come to the lab and we can work together again, together on it, figure it out, finish it, maybe try out some other stuff. If you feel like it, just come over. Now I'm going to leave you to open the lab document and try to work a little bit there. You might want to do that a little faster. I'm sorry again for the delay. Again, terribly sorry that we couldn't finish this. I promised that it was amazing, as I had planned it. But so a quick wrap up, because inspiration talks start soon, and those are going to be amazing. So what we almost learned today was about observables and operators that we saw, how to produce these asynchronous collections that you can over time do things with. Then we saw a little bit of RxSwift in practice, so how to combine and design this very straightforward workflows. Here's the data being produced, bind it to that UI control, or here's the data, store it somewhere else, and so forth. So if you work on your own on the lab, or you come tomorrow morning and see me and then we can work together on it, you will see then how these observables that we defined get bound to the UI, and then how the whole app works completely. Again, if you don't want to come tomorrow morning, you can just run the finished project from the lab folder and see it done. So either way, I hope that this was at least interesting, if not inspiring or amazing. Right. We have a Getting Started with RxSwift and RxCocoa tutorial on the website. So if you want to see a little more of the basics that we just rushed through and jumped over partially, you can go to remodelink.com and have a look at that tutorial. There's a rxswift.org will take you to the GitHub repo for RxSwift. And rx-marin is a little blog where I sometimes put some RxSwift tutorials and articles. With that said, thank you very much for coming, and I hope that you're as excited as I am for the inspirational talk that are starting right away. Thank you very much.